Chapter 3, Section 2, Addition and Subtraction Properties of Inequalities. In Chapter 3, we're looking at the addition and subtraction properties of inequalities. We're talking about equivalent inequalities, like 3 is greater than -1, and also (3) is greater than -1, but now we can add 5 to both sides of the inequality and keep the inequality equivalent. 3 plus 5 is greater than -1 plus 5. So 3 plus 5 equals 8, and 8 is greater than -1 plus 5, which equals 4. 3 is greater than -1 is equivalent to 8 is greater than 4. We added 5 to both sides, so we know that it is going to be equal. It is important to have equivalent inequalities when we're solving for a variable. So if I have x plus 5 is greater than 2, I can solve for x by keeping this inequality equivalent. So because I have plus 5 here, I know I need to subtract 5 from both sides to make that positive 5 into a 0. 5 minus 5 gives me 0, but if I do it to one side of the equation, I have to do it to the other, just like in equalities. So 2 subtract 5 gave me -3. So now I have x is greater than -3. That is the solution to my equation. I can graph this solution on a number line. I know that I'm going to have an open circle at -3 because I have a greater than sign and it is not greater than or equal to. So we're going to make, if I can find the right tool, we're going to make a number line, and I know -3 has to be somewhere on that number line. Having a little difficulties here, bear with me. Here we go. So I have my number line, I know I have arrowheads on both sides. I know I need -3 somewhere on here, so we'll do -4, -3, -2, -1, 0, and 1. Again, I'm looking at my sign. I have a greater than sign, not greater than or equal to, so greater than is going to have an open circle. And the open circle, remember, is not filled in. I'm going to put that at -3. Now I need to look. X is greater than -3. So which numbers are greater than -3? -2, -1, 0, and 1. Those are the ones that are greater than. So I'm going to shade in that side of my number line. Make it nice and dark so we can see that we clearly shaded it in. And we're going to fill in the arrowhead as well. Now it shows me that all the numbers are the solution. So -3 works, -3.5, -2, 0, 1 million, they all work. So here's another problem. This problem says m minus 11 is greater than or equal to -2. Big thing there, greater than or equal to. When we get to graphing, we're going to talk more about that. So where I have m minus 11, I know I need to do plus 11 to make that 0. The opposite of subtraction is addition. So then I add 11 to -2 as well. -2 plus 11 gave me 9. So now I have m is greater than or equal to 9. So when we graph this one, I make my line, make my arrowheads. Where are my arrowheads? Oh, sorry, we're talking about something else right now. So I'm talking about the fact that I need to have a closed circle, a filled in dot, because I have the equal to part in that greater than or equal to filled in dot. So I made my number line 4, 5, 6, 7, 8, 9, 10. 9 is on there somewhere. We're going to put a closed circle, a filled in dot at 9, and we need to look. M is greater than or equal to 9. So which direction are we going to go? So for numbers bigger than 9, we know 10 is bigger. We're going to fill in the side that has 10 on it, and we're going to color in that arrowhead because 1,000 is bigger than 9, 400 is bigger than 9, all of the numbers we need. So now we're going to see if this is right. We're going to check our answer. So I need to split this into two different problems. I need M is greater than 9, and I need M is equal to 9. So we're going to be substituting 9 into the equation like we would with an equality, even though this is an inequality. But here we're going to see that we can't substitute 9 in for when it says greater than. We need to pick a number that is actually greater than 9. What numbers could be greater than 9? Let's try 10. 10 is greater than 9, and it's only one away. Makes it easy for us. So 10 subtract 11 is going to give me -1. And I keep the greater than sign, and I keep the -2. Is -1 greater than -2? Yes, -1 is greater than -2. It works. So we've checked that part of it. But now we need to check M is equal to 9. So this is the time we're going to substitute 9 in because we have equal to. So when we substitute 9 in, we have 9 minus 11 is greater than or equal to -2. But I don't want greater than or equal to using the equation. I want just equal to in this case. So I have 9 minus 11. That gave me -2. Is -2 equal to -2? Yes, it is. So that checks. Both of these check. So that means this solution worked for our equation. Moving on, we have -1 is greater than or equal to y plus 12. Notice that this y is on the left side of the equation. Our variables can be located on either side of the equation. In this case, it's on the left side, on the right side instead of the left side. So we're going to solve as we would for any equality, even though this is an inequality. We subtract 12 from both sides because positive 12 subtract 12 is going to give me 0. I'm going to subtract 12 from the other side to keep the equation balanced. So I have -1 subtract 12, which gives me -13. I rewrite what I have. I have -13 is greater than or equal to y. We can also read this, y is less than or equal to -13. When we're graphing, this can be very important because we have to remember that we can read left to right or right to left. So I know I need -13 somewhere on here. So I got -13, -12, -11, and -14. I know I need what type of dot? I need a closed circle, a filled in circle for my dot at -13. So I go up to my number line and I do that. I fill in the dot. But now I need to decide which direction are we going to go. Remember again, I have -13 is greater than y. So if -13 is bigger than y, I know y must be less than -13. Notice that the symbol has the open part to the 13 and the pointed part to the y. That's how we know that it's less than. Y is less than -13. So we need a number less than. Is -14 or -12 less than -13? -14 is. So we're going to make sure we shade in that side of the equation. And when we shade it in, we make sure we fill in the arrowhead to say that it's going in that direction forever. And we can check this as well. I'm writing the equation to check with y on the left-hand side because I find it easier to read left to right like we do in English. So I have y is equal to -3 and I have y is less than -13. Oops, that needed to say y is equal to -13. Let me fix that. There we go. So now when we test it, remember we're going to substitute in for when it's equal. So I have -1 is greater than or equal to, nope. I want just equal to. So negative 1 is equal to, substituting in negative 13 for y, negative 13 plus 12. And negative 13 plus 12 gave me negative 1. Negative 1 equals negative 1. That part checks. Now we need to check the other part. Remember, when we check this part, we need something less than negative 13. So what number would be less than negative 13? So we put into the equation, negative 1 is less than, negative 14 is less than 13, so put that in there. Negative 14 plus 12, negative 1 is greater than, now negative 14 plus 12 is negative 2. Negative 1 is greater than negative 2, so that works. Our solution checks in both cases. We know it's correct. So what we need to remember from this section is that y is greater than 3 is the same thing as 3 is less than y. When we read them left to right or right to left, we need to make sure we read them correctly. We also know that y plus 2 is greater than 3 plus 2, because this is the addition property. We add 2 to both sides, it still works. And y minus 2 is greater than 3 minus 2, because if we subtract 2 from both sides, it is still equal. So that's all for chapter 3.